Howdy, y'all. Well, since the housing data decided that it didn't like it when we tried best subsets, we're going to try the wine data because it's a smaller data set. I am hoping this works better. Sorry that it crashed and didn't want to do it. That didn't happen when I tried this on my home computer, so that was a bit of a shocker for me. Anyway, so this data is the wine data that we used last week, so I'm hoping this looks familiar to you. It's got all the chemicals in here. We're going to try to predict aroma, but we're going to do it using best subsets. Hopefully that's exciting for you. I got all my free predictors. Woo! Sorry. And hopefully it won't crash. Yeah, we're good. Let's do this. All right. So this is what it typically looks like. Make this a little bigger for you. Okay. So up here, it's got the variables that it's using, and it's selecting which ones you should be picking. So it also arranges this by r squared, not adjusted r squared. So just so you're aware of that. So what I do when I go through this is I typically look at your adjusted r squared and your s and try to pick the best one I can off of here. So if you look at adjusted r squared, it appears like the middle ones are the best. They're all around 60 something, or 65 something. So like this one does a pretty good job, and so does the 8, 9, and 10 ones. So then the next thing you want to look at is the S values and try to see if you can find the smallest one possible in here. So like this one is pretty darn good. I'm hesitant to call it the best version, but it looks like that's it. So it looks like um, it's got the highest r squared you can get out of this. And then, yeah, it looks like it has the smallest S value. So I would probably pick this one. Mallows cup value, that's a test statistic that oh God, I don't remember what this one does, to be honest. I remember small is better. Maybe I'll do a separate video on how to judge the Mallows cup. I'm just trying to do this in a hurry, which I apologize. So it appears that these, so these indicators are the best ones. So we would use cadmium. I don't remember what MO is. Copper, chromium, strontium, magnesium, calcium, and potassium made an appearance. That's kind of a shocker, but potassium looked a little, quadratic in nature, so I might need to fix that, and that would probably actually make the adjusted R squared even higher. So, there you go. That's how you would do the best subsetting. And like I warned you, sometimes this will not work because it is such a large data set, but luckily the wine data is small enough to where you can do this. So again, when you're trying to pick from best subsets which one to use, it literally does all of them, okay? All the possibilities. So if you're looking across these X's, it's doing lots of different combinations, including the option of let's just use all of them, which is at the bottom. Um, so if you look here, you would look for first the biggest adjusted R square value that you can find, and then amongst those, look at the S values and try to pick the smallest one you can. So I think this is a good selection because it is a very high R squared value and a very low S, one of the smallest you can achieve. So this is a good model. This is the model you would pick from using best subsets. Alrighty. Hope that made it clearer than the last video what you should do. And thanks for listening.